Company is Energy Revolutions Corporation, okay, energy-revolutions.com. We're a full green building company, full turnkey operation, so we're doing solar PV, wind energy, geothermal. We're looking at energy efficiency, energy audits. We'll go into existing structures and help the owner try to get, closer to a renewable energy stance or a more sustainable home, whether that's insulation, whether it's better windows. There's two separate markets there. One is new construction, one is existing construction.
Since we live in the New England area, we're looking at usually existing.
Exactly. Maybe 100-year-old structures.
Right.
Yeah. They've been around a while.
And people really want to do this.
Right.
And so we need to explain it a little bit.
Well, this concept of a vertical wind turbine is a little different. It has a number of benefits to it that are a little different than a horizontal design. One is that it's silent. The wind, as it's entering, exits in a nice fashion. A horizontal design where you have blades that are out spinning are traveling at their tips faster than the wind speed. So that's where you're going to get the whooshing sound. Okay. At this point, it's literally like an airfoil, just like an airplane, and it enters and exits without that kind of a whoosh.
What is the minimum wind speed where they work?
They cut in at 4 miles per hour, which is about half of what a horizontal design needs. So what happens?
They don't have to shut off when they get.
They don't need to shut down.
They don't need to shut down.
In fact, just as a proof of product, we're currently installing one of these units on top of Mount Washington. Just to give people, in fact, there is a picture in here. Where is it? There we go. There's one of the units on top of Mount Washington.
This is actually the size of it.
That's the same size. Now this, to give you an idea of the severe conditions up here, Mount Washington has had the highest recorded wind speed of anywhere on the planet of over 230 miles per hour. They get 100 days a year at hurricane category 1, which is 75 miles per hour.
Yes.
They have an unusual situation up there called rime ice, where the wind speed is so intense that ice grows horizontally into the wind. It's very unusual. But because this unit is spinning, especially at that speed, it's going to throw off anything that would try to attach to it. So it's not really an issue up there. So
How did it perform?
Well, we're actually, the second version that's going up here is going to have a top mount, so it's even more stable. That should be going up in the next 2 to 3 weeks.
Now, how much will this generate?
This is a 1 kilowatt version.
1 kilowatt.
Now, on top of Mount Washington, that might be considerably more, but on an average, the average wind speed, the nameplate capacity is typically going to be reached about 1 kilowatt.
How many would you need on let's say, a one-family house?
Well, it depends on how many square feet the house is, too. Typically, an average home, say 2,500 square feet, 3,000 square feet, is about a 3 to 4 kilowatt usage. In terms of it depends on what's in the house, though. How are they heating the house? Are there Energy Star rated appliances in the house? What kind of windows are in there? What kind of insulation does the house have? How much of that heat is being blown out through the windows, blown out through the walls?
Suppose someone did their homework and they had all the insulated windows, geothermal, the way people are going.
Well, if we're talking full green building, there's technology today that you could create a house that was so efficient you could heat the entire house with a space heater. In fact, it's already being done.
It's they call it super insulated.
Yes.
So if you have a highly efficient insulated home, how many of these and what size would you need?
Well, from one space heater, theoretically you could do it with one. But it depends on your appliances. So it depends on the washer and dryer and the dishwasher and everything else that you need in the house. So theoretically, 3 might be typical, 3 kilowatt.
How would they compare with the photovoltaic installation? What is the?
In my opinion, the two should always go together. Okay, because if the sun is not shining at night, you're going to get wind power. And in fact, statistically, we get more wind at night than during the day. So this thing is going to be producing power anytime the wind is blowing. So that means at night, when solar is not doing anything, in the daytime you got a beautiful day and there's no wind. Plenty of sun, this is going to be holding still.
So your company, Energy Revolutions, is promoting what nature has to offer, whether it be the sun or the wind. And so how many sizes of these do you have?
We have 3 different sizes: a 1 kilowatt, a 5 kilowatt, and a 10 kilowatt.
And where would you use? This is a 1 kilowatt. Where would you use? Now, what's the other sizes?
5 and a 10.
And where would you use the 5 kilowatt?
Typically, all 3 would be residential. Typically,
Would there be any applications for industrial? Say, I've got a
multiple
mall,
units.
a shopping center, a store.
Yeah. Yeah, you could do multiple units across the top ridge. There you go. This is a proposal we have in place. This is another one at the Harvard Business School.
So essentially what you're telling me is that I could put enough of these up here to offset the entire electrical needs of this building?
Possible.
It's possible.
Yeah.
And at what sort of rate of return? How long would it take me to make my money back?
Well, it really depends on the location, because you've got wind speed to be considering.
You still have to put like an atomometer out there. And
you need to do a test of the area, exactly.
Now, there are also prohibitions on
Height
licensing for putting this in an area.
Permitting. Yes.
How loud is it?
Well, that's another nice thing too. They're quiet. There's no sound coming out of this.
No sound?
No.
Do you have a decibel reading? What kind of number can you give me?
Probably we could carry a conversation on like this right in front of it, and you wouldn't really be hearing anything. So in terms of relative point of view, you're basically going to be hearing the wind.
Oh.
Okay.
Yeah.
So that's amazing. Do you have any idea of what cost, say on the average of an average home? So many people want to do this, they have no idea.
Right.
They want to do this.
Yes.
But then I heard that you have to have a certain amount of land, and the permitting process has to go
Good
on.
question. Yeah.
Okay.
Well, the cost and the return on investment is basically the bottom line. Everybody wants to know.
Right.
Okay. Is this feasible, and how long is it going to take me to return the investment that I've made? The bottom line of that is currently we have a wonderful incentive package that just went through Congress, which gives homeowners 30% tax credit.
30% tax credit.
Yes.
That's available now?
That's available now.
Is that just becoming available? That's good.
That's very good. Yeah, that just happened in the last stimulus package.
Wow, that's good.
Yes.
Are there any other any other state or local
There are.
programs?
Massachusetts Technological Collaborative also has another one, which I believe they have a table here at the event.
You know that.
You know them. Good. I would definitely bone up on what they're doing, because basically what they're saying is that the data loggers that a homeowner would put on this, in other words, their intent with the Massachusetts Technological Collaborative is to try to help homeowners get a handle on what the unit is actually producing, regardless of what the manufacturer says it produces, and give a good handle on that, and then also help fund the installation. So the idea is that you put data loggers on this, you send them the data, they amass a database of the information to help the industry grow and mature. In return for that, at a 1-year anniversary, they cut you a check for about $2 per watt with a $35,000 cap. So there's actually quite a good incentive there.
That's a great incentive.
Yeah, that's in addition to the tax incentives.
Now what about the permitting for having so much land around? This is what
Another
I've heard
good question.
people say.
Yeah.
Now I really have to know that, because many people want this.
It's all
but they
different.
don't have that
It's all
land.
different. For example,
how do I find that out?
locally, you're going to have to go to the zoning board and find out, or the planning board, or in some, especially in New England, we have a lot of historical convening boards. Nantucket is one of the places that we've installed, where actually one of our corporate offices is, and we have a historic commission that anything has to go through. Well, currently they're operating on a 20-year-old statute that says if you have a wind turbine, you need 2 acres of land.
Yeah,
Okay?
Now they're talking about any kind of wind turbine?
Any kind. They had never even seen this.
Oh, okay.
And they didn't realize that these don't have to be at 100 feet.
Right. They don't, what do they have to be at?
Well, again, it depends on the wind, depends on the location. But because these are more efficient, we can actually lower them to maybe half that height, or even lower. And the lower you go, the less energy you're going to create out of the unit because of laminar flow. You get a turbulence happens at the surface. As you get above, the tree line, you definitely have to get above tree line. You want at least 10 feet above tree line. That's what we want to see as a minimum. So if you do a roof mount, you might be at that height. It really depends on where you live. On Nantucket, the tree line is about 30 feet. So if we were at 40 feet, now you're looking at a safe zone that's only 40 feet around that that pole instead of 100 feet, in which their concept is they're trying to mitigate your tower blowing over into your neighbor's yard.
Yes.
That's why they need that 2 acres.
I see.
Okay.
So you're saying in every region, it's different.
Yes.
So you really have to find out.
And a lot of times what we're doing is getting variances on existing statutes that might be outdated because new technology is changing things.
So you could look for a variance.
Yes.
But the design of this is so different, though. Instead of a propeller-based system,
What is the cost?
Well, the cost, the 1 kilowatt is about $4,500 for the turbine.
500.
Yeah.
$4,500. That's not a lot of money.
That's very handable. I had there at $30,000.
Well, you're getting up into the 5 and the 10 kilowatt. The 5 kilowatts about 27, the 10's about 37.
So you could have 2 of these and have a semi-efficient,
You bet.
efficient house.
Well,
run everything.
Yeah,
on
if you look at the whole structure, you do an energy audit, you say, okay, I'm going to have better windows, I'm going to have better insulation, I'm going to get Energy Star rated appliances. That's the first step to reduce your need.
Right, reduce the need for
Then
noise.
you do multiple sources of renewable energy. You put PV on the roof and wind,
Right.
and you need a smaller wind turbine and a smaller array of solar panels because they're both backfeeding as a negative load into the net metered solution.
This would be good for in the city, all of these
Exactly.
triple decker or whatever, flat roofs in the city.
Right, all the flat roofs.
Some
And of course,
photovoltaics.
if your home is insulated with a efficient insulation product, and I happen to be a dealer for Icynene foam insulation,
Oh, we were just talking this in home.
and when you're insulating a home with a truly effective insulating product, that's going to bring your energy costs down substantially.
Yeah.
Then you take all the other Energy Star energy saving components on top of it,
Right.
add this on top of that, and now you have a machine which is self-fulfilling. It's going to cycle itself on a positive nature, pay for itself, contribute to the grid.
Yeah.
Yeah. Absolutely.
Another really good question. The actual design, the double helix design, is probably over 20 years old.
Really?
It's been in Europe.
Have people seen it in Japan?
Yes.
Someone told me they'd seen video on this.
Japan, China, England, Finland, a number of places. It's been in Europe more than it's been anywhere else.
What do you think is holding it back? Because so many people are interested in this, want to do it, can't get enough information about it for the town. So what is holding this back?
Well, first of all, it's new. So it's not about...
It's new here in the United
PV has been around for 30 years, and the main reason that it hasn't been adopted is because of the upfront cost. It takes a lot of forward thinking. So a lot of times you have an upfront cost you have to amortize out over a period of time. Many homeowners aren't willing to do that, especially in hard economic times. So the real issue becomes forward thinking. If I spend a little money now, how much money am I going to save in the future? And then what is my return on investment? How many years is it going to take for me to actualize my investment, and then recognize that after that point, it's almost free energy at that point.
So you should be offering people formulas where they can, I think that's what people are missing. They're sitting in houses, they can't figure it out.
I know, they want it.
If they would be having a formula where they can figure this out.
Well, let me answer it further, because what you're saying is just so appropriate. Because while technology is great, if it's not explained in an emotional, compassionate way that actually gets people motivated, if you get somebody with a brand new product that's all so excited, you get all the data, you get all the numbers, your eyes gloss over. It's like too much data. What you really want to know is, how does it feel? What's the emotional response? Could I actually mitigate my costs of the rising cost of the fuel for my house, where I'm seeing maybe my retirement start to be dwindled away because the energy costs are going up and up and up? Wouldn't it be smart to say, if I invest this much now, I won't have any rise in cost of my energy? If it's related in that way, then it makes sense. All of a sudden the light bulb will go off. But if it's how many kilowatts am I going to produce? What's the return on investment? What's the tax? It's like,
I know.
Which is exactly why people are finally now paying attention. It wasn't until the oil prices got so high that people started going, wait a minute, maybe I should give my SUV back. But then the real switch that was thrown was when the stock market went south, and now people are taking what little money they have left, and they're saying, this is now precious to me. and I'm going to make the very best use of what little money I still have. So now, even though the gas prices went down, that hasn't had the impact. What has had the impact is the fact that people now, they treasure what little they have. So now they're looking at ways to super insulate their home. Now they're looking at ways, oh, you mean I can actually contribute back to the grid? Well, yes, and you've been able to do it for 20 years.
I know.
But now the data doesn't bother me. What bothers me is my pocketbook. And now I'm interested.
There was
I think a large piece, though, is the education.
Yes,
because
clearly.
The towns, the people in charge,
Here-
people have to
Did
know.
you see the article? It was in the Northeast Sustainable Energy Association's newsletter that was just the last edition. There's a great study group. Basically, there was an affordable housing project with about 20 homes. They gave the homeowners, the new investors that are coming in to own these homes, they gave them a choice. Would you rather have conventional building methods, meaning a regular insulated home, normal windows, an HVA system, or what if we built your house with super insulation, triple glazed windows, and made the system so tight and so efficient that we could take out the HVA system and you wouldn't even need a heating system. What happened was, if you looked at the cost of the building, it was going up like this because of all the extra costs for the super insulation, the super better windows, and it went up and up and up. As soon as they took the HVA system out, it dropped right back down to the same cost as all the other buildings.
Wow,
Now
that's
here's
amazing.
the kicker.
Yep.
They went before all these people, and the builders told them, the people that were considering it, they told the people they were nuts. They said, you can't be in New England and have a structure without a heating system. The architects told them they were nuts. So they were like, so out of the 20 homes, only 9 people gave it a try. They went back and interviewed those people a year later. They were overjoyed. $4 a month is what it cost them to heat the house.
That's amazing.
And they paid as much as everybody
One
else.
step further.
Yeah.